Your answers, and if you compare them to your classmates, might be a little different depending on if you rounded up or if you rounded down. If you didn't have to round at all to figure out how the pieces of the pie, you would see that there was exactly one whole pie is left over. So take a moment and think about, why is it a problem for a computer if your answers are different than others? Computers are really specific, and numbers represent, our binary numbers represent information. And so if our numbers are different, that presents a problem for how a computer can interpret them. So, two things I want you to think about and jot some ideas down. What does the binary odometer show about representing large numbers? What does the Flippy Do Pro show about representing very small numbers? And lastly, if we had a big enough odometer or Flippy Do Pro, could we ever represent every possible number? With a fixed number of bits, so that means like a certain number of bits, doesn't change, computers can only represent a certain set of numbers, fixed numbers. And that can present a problem. And these are two errors that happen. And we saw these errors in lesson 5. One is called an overflow error. And this error is an error from attempting to represent a number that's too large. So when your odometer maxed out and went back to 1, that's an error. The other error that we experienced is called a round off error. And it's an error from attempting to represent a number that's too precise. So the value is rounded. And so we saw that with our pi example. In your notebooks, make sure you have a definition of both overflow error and round off error. So lastly, in Nearpod, after this video, you'll see two open-ended questions for you to answer. Answer them, and then you are done this lesson. Have a great day, and I'll see you on Tuesday.